Hello everyone, this is Bartosz Kotusiewicz from 3D Infotech. I'm Senior Account Manager and I'm hosting for you with our webinar Spotlight AR++ on the shop floor. And together with my colleagues from Budapest, Tamas Liptoy and Daniel Szarut-Falvi, we are going to introduce you to our augmented reality software. Actually, our Spotlight AR++ may be utilized for two main purposes. This is augmented reality assembly guidance and also augmented reality metrology guidance. After this webinar, you will know for sure what does it mean and how this software can improve your business processes, especially production processes and measurement processes. But before that, let me introduce you briefly to our company offer, portfolio and history. I will present you a few slides of our company presentation and will explain what you can expect from our augmented reality Spotlight AR++ software. So join me for this short presentation, and after that my colleagues will present our product to you. So let me introduce you briefly to our company. 3D Infotech was established in 2005 in Irvine, California by our CEO Rohit Khanna, and we have been 3D software and hardware solution provider since then, providing quality control automation and adaptive manufacturing applications to customers from variety types of industries, mainly manufacturing. So we are manufacturer, software developer, and integrator of the solutions that feature best-in-class computer vision, artificial intelligence, and robotics. So our aim is to help our customers increase their productivity, quality, and implement automation, especially in their measurement processes. So we have nowadays 4 facilities worldwide. Our headquarters are placed in Irvine, California, US. We are also operating in Latin America from Querétaro, Mexico, in Asia Pacific region from Suzhou, China. But most importantly for our today's webinar, we are covering Europe businesses from Gudullo near Budapest in Hungary. For over 10 years, we are having their software development department, production facility, and also support and maintenance department, and all of that is provided to our customers by over 20 people that are employed there. Most of them are engineers. So our factory floor application may provide 5 types of solutions to our customers. So first of all, we are in dimensional inspection business. This is our main business to assess geometric characteristics of machined parts, products that are being produced. We are also providing visual inspection solutions that utilize machine vision cameras. Both of them may be utilized for adaptive manufacturing, which means the results obtained from these sensors are influencing the production by, for example, changing the production program in CNC machine. So factory floor application from Industry 5.0 era are the ones that extensively collaborate with the operators, with human factor, let's say. So CMM tending, we are adding our cobots to old school CMMs and supporting operators in manipulating the inspected objects, while assembly guidance and also the metrology guidance are, today's topic. And we are supporting on the floor operators, workers with the projection of the results on the physical parts. We are projecting the inspection results, but also the working instructions. So, as I said, we are developer and producer, manufacturer of our products, and we include in them top-notch, widely known vendors. You can see here on the slide. I would like today to mention that in our Spotlight AR++ software, we are, and also hardware part of this solution. We are utilizing the software from Innovmetric, which is Polyworks, from Christie, which is responsible for our top-shelf projectors, and also cameras from Flare, Alight Vision, Basler, or even Cognex and Keyence. So, when we are talking about automation of the geometry measurement, we are talking about actually a universal machine automation. This is UMA in our nomenclature. So in Goodle, we are producing the stations, inspection stations like Smart Desktop, Smart Station, or Smart Cell to inspect with, for example, laser scanners or structured light scanners, small-sized, medium-sized, or large-sized parts. And we are integrating with our produced stations the sensors or cobots from our vendors. So usually our station consists of rotary table of our production, sensor, cobot, and robot, operator stand that we produce, and Streamline software, which is our proprietary software developed by us in-house. When we are talking about automation of the machine vision and inspecting with machine vision the products, we are talking about universal machine learning because we are also utilizing the AI technology into it. If we are putting the machine vision cameras on our inspection stations, like Smart Desktop here, to read, locate the products, read labels and markings, classify the products, or analyze the defects on the pipeline on the shop floor. The heart of our system is our proprietary software. We are developing Streamline in US and partly also in Godullo. And Streamline is powering the system that usually consists of the 3D scanner or camera or 3D sensor. It may also power and control the CMM, and everything is attached to our motion control system, which are our inspection automated stations produced in Hungary. So I would like to show you what we are actually going to show you today. This is another software we are developing called Spotlight AR++, our augmented projection system. So it can be utilized for two, as I mentioned, for two reasons. So first of all, it is for metrology guidance. So after you inspect with the scanner your product, then you have the results, for example, color map of deviation, and you can project this result on the, actually, for example, here, car body, any product, with features and with their dimensions and their description, and also what is accepted or not, what is in the tolerance or not. And the other objective is actually the Spotlight AR used for assembly guidance. We can also project the work instructions so they can be showed to our workers, to our operators. We can use 2 or 8 projectors, and they can project the instructions, what is assembled properly, improperly, and also the guidelines for the operators. How it looks like in reality, here you can see here the instruction and different type of the lightning of the different type of colors that indicates different types of activity. From these flagship customers, I would like just to underline that Northrop Grumman is utilizing our Spotlight AR++ for assembly guidance, while PCC Precision Cast Parts in the forging industry is utilizing it the same system for metrology guidance. So with no further ado, please Daniel and Tamas take the lead of this presentation and present in more detail our system.
Hello and welcome to our webinar about Spotlight AR++ on the shop floor. So Spotlight AR is a software that is developed by 3D Infotech, and it is an augmented reality solution. My name is Daniel Sarutfalvi and I'm an application engineer at 3D Infotech. So augmented reality is an interactive experience that combines the real world and computer-generated 3D content. The history of augmented reality is a result of a long process of development dating back to the 1690s, when the foundations of the technology were just being established. The evolution of augmented reality is closely linked to the advancement of virtual reality and computer graphics. In 1968, Ivan Sutherland created the first head-mounted display, which was known as the Sword of Damocles. This was the first device that allowed users to see simple 3D graphics projected into the real space. In 1974, Myron Kruger developed the VideoPlace system, which allowed users to interact with a virtual environment in an interactive manner. Although this system didn't project images into real space, it combined human movement with computer graphics. In 1992, Louis Rosenberg developed the virtual fixture system for the US Air Force. This was the first true augmented reality system, allowing users to see and interact with virtual information overlaid on the real world using mechanical arms. In 2003, augmented reality began to be applied in healthcare, particularly in surgery, where augmented reality systems were used to support surgical procedures by projecting virtual information onto real body parts for surgeons to reference. In 2012, Google introduced Google Glass, wearable augmented reality device that allowed users to view and use information without the need for a screen. In 2016, the release of Pokémon Go revolutionized AR's application for the public. The game allowed users to hunt virtual Pokémon in the real world using AR technology based on GPS location. This was the first hugely successful AR game gaining worldwide popularity. The same year, Microsoft introduced the HoloLens AR glasses, which used advanced 3D holographic technology. HoloLens enabled users to display and interact with 3D holograms in the real world. In recent years, augmented reality has become more widely accessible, particularly through smartphones and tablets. In the future, AR technology is expected to gain even more ground through wearable devices such as smart glasses and head-mounted displays. And let's have a look at the augmented reality type. The first one is the marker-based augmented reality. In this type, the augmented reality system uses a predefined visual marker, such as an image or pattern like a QR code, to display digital content. The camera detects the marker and displays the virtual object or information at the marker's location. For example, a 3D animation linked to book covers marker that appear when scanned by an AR application. The next one is called markerless augmented reality. This type does not use these predefined markers. Instead, it uses devices sensors such as GPS, accelerometer, gyroscope, and digital compass to align the virtual objects with the real world based on the user's position and movement. A good example for that is the like AR games like Pokemon Go, where virtual creatures appear in real space using GPS-based location tracking. The third one, I highlighted this one because Spotlight AR is this category, is the projection-based augmented reality, where digital content is projected onto the real world without the user needing to look through a device like a phone or glasses. This AR works by physically projecting images into the environment. Like, for example, in interactive exhibitions where digital content is projected onto walls or objects, allowing users to interact with the projections. The next one is the superimposition based. This type partially or entirely replaces the real world view with a digital layer. The AR software recognizes an object in the real world and overlays virtual elements directly onto that object. For example, a good example for that, those applications that place virtual furniture in real spaces, like in retail applications. The next one is the location-based augmented reality. This type primarily relies on location-based systems such as GPS and other sensors. Virtual content is anchored to the user's geographical location and linked to real-world objects or places. For example, tourist apps that display information about landmarks in the user's vicinity. And lastly, the wearable augmented reality. In this type, users view virtual information through wearable devices such as AR glasses or helmets. It is especially useful in industrial settings, healthcare, or education where hands-free operation is important. A good example for that is the Microsoft HoloLens, which projects 3D models into the user's field of view. The application areas. Augmented reality is becoming prevalent in a variety of fields, and as technology evolves, its possibilities continue to expand. In education, AR can make learning more visually and engaging and interactive. For example, during a history class, students could see 3D models of historical buildings or events, enhancing their understanding. In gaming and in entertainment, like AR games, Pokemon Go became globally popular as they allow players to search for virtual characters in their real-world surroundings. In healthcare, medical imaging and surgery, AR can assist doctors in visualizing internal structures more clearly, providing more accurate guidance during procedures. In retail, customers can try products virtually before making a purchase. For instance, certain apps allow shoppers to place virtual furniture in their homes to see how it fits into their space. And lastly, AR is often used in simulations and guidance where virtual objects are added to real-world environments, enabling realistic practice scenarios in an industrial use. Spotlight AR++ offers versatile solutions, including defect visualizations with data color map projection, assembly guidance, and measuring support such as probing. It also enables dynamic projection capabilities, making it easier to inspect, guide, and measure with precision during various manufacturing and inspection processes. Spotlight AR++ enhances the inspection process by projecting data color maps for easy visualization of defects. It supports repair and rework procedures by displaying real-time guidance and highlights features directly onto the surfaces, ensuring precise correction and improved workflow efficiency. Spotlight AR++ provides comprehensive assembly guidance by projecting real-time instructions, wiring routes, schematics, and parts directly onto the work area. It ensures accurate positioning and seamless assembly processes, enhancing efficiency and precision during difficult tasks. Using Spotlight AR++, specific probing points are projected directly onto the surface of the car chassis or the desired part in real time. These projections serve as clear visual guides, allowing the operator to see exactly where each measurement needs to be taken. This eliminates any guessworking or manual referencing from external guides or software, making the process more efficient. Spotlight AR++ dynamic projection uses augmented reality to project real-time visual guides directly onto physical surfaces. This technology provides operators with precise instructions, measurements, or assembly points, dynamically adapting as they work. Spotlight AR++ ensures accuracy and efficiency by displaying relevant information exactly where it's needed on the part itself. This real-time projection reduces errors, speeds up workflows, and enhances overall productivity. Thank you for your attention, and now Tamás Liptai is going to continue with the data color map projection.
Thank you, Daniel. Welcome everyone, my name is Tamás Liptai, an application engineer experienced in metrology automation, reverse engineering and augmented reality with projectors. Let's take a look at one of the possible industrial applications of Spotlight AR++. We will demonstrate that on a door next to me. First of all, in order to show our software in action, we need to acquire raw data from the vehicle door. First, we need to scan the door. After that, we can evaluate it in Polyworks and then display the results on the door itself. We will perform the scan using the Scantech TrackScan P550. For object of this size, this scanner is a perfect solution. It's compact, scans quickly, it has got a big volume, thanks for the tracker. Once the scanning is done and our mesh is ready, we will import the data into Polyworks, where everything is already available. We have the features to be evaluated, the color map, and I would like to point it out that we have to create alignment points on the CAD model, which are crucial for the projection. Without these points, the projection would not be possible. It is important to be placed these points on the part's specific geometric elements, such as corners or unique features, and as widely spaced as possible to increase the accuracy of the alignment. These alignment points are considered as custom measurement points in Polywork. Now, let's see the result that we got. Here you can see the projected color map on the door. It is very easy to spot at a certain point that there is a dent on the door. The color map indicates this with a strong purple color, and now I am going to mark this dent with a marker pen. One of the best applications of Spotlight AR is when we are looking for defects on the surface that are difficult to identify and possibly trying to correct them. For example, if we scan a part with a flat surface that doesn't meet the desired manufacturing parameters, we can scan it and it becomes visually apparent where the surface is uneven. Then we can deliberately target the areas that need additional work to meet the desired quality control standards. After the surface has been repaired, we can rescan the part and project the new color map onto the surface based on the updated data. At this point, we can see again what results have been achieved. If everything is okay, the part has passed the inspection. If not, in this case, the process must be repeated. I can also demonstrate this example on the door. Let's assume that we take the door for reworking and measure it again to see the operator successfully made the corrections. Let's see the result. Okay, here you can see where I marked the surface. It has been repaired. This kind of solution is excellent because it helps metrologists to visualize surface defects on the part and clearly identify them, even if they are not visible for the naked eye. Furthermore, it is not only possible to project the color map onto the part, but also display the measured values of the geometric features. For example, on the door in front of us, we can project the nominal values of the holes, the measured values, and the difference between the two. This is the deviation. We can project images or descriptions on the surface. Additionally, Spotlight AR indicates whether the dimensions are passed or failed. In summary, this solution improves efficiency in manufacturing process, helping metrologists to immediately visualize surface defects and mark them with great accuracy. Moreover, technicians don't need to wear an AR glasses during shifts. It could be uncomfortable to wear it for a long period of hours. It could strain their eyes due to the bright lights. With Spotlight AR++, it is sufficient to use a projector. It can simply be mounted on a tripod to remain in a fixed position. Additionally, using Spotlight AR++ with a good projector, a good scanner, and with a good laptop, we can immerse ourselves into augmented reality. Thank you for your attention. Now I'm giving the mic to Daniel.
Thank you, Tamás. In our next section, I'll walk you through the process of using Spotlight AR++ for guided measurement inspection, specifically focusing on a car door, and the integration of the Scantech TrackScan T-Probe with Polyworks Inspector. Let's start by imagining that we need to inspect the dimensions of a car door, as you can see it projected on the surface, a common task in automotive manufacturing quality control. Instead of manually marking and measuring specific points on the door or referencing external guides, Spotlight AR++ simplifies this process through augmented reality. Here's how it works. Using Spotlight AR++, we can project the exact probing points onto the surface of the car door in real time. These projections are directly aligned with the door, so the operator knows exactly where to position the probe. As you can see, the points appear clearly on the surface, ensuring that there's no guesswork or misinterpretation. Each point is dynamically highlighted, guiding the operator to follow the inspection path step by step. The next piece of technology in this setup is the Scantech TrackScan T-Probe. This tool is designed to capture high-precision measurements and is perfect for this type of guided inspection. As the operator moves the T-Probe to each projected point on the car door, the system tracks the probe's position in real time. The T-Probe works seamlessly with Polyworks Inspector, which records each data point with high accuracy. As the operator follows the projected probing points, Polyworks automatically gathers the measurement data, ensuring that each point is captured exactly as required. The Spotlight AR++ projection system ensures that the operator never misses a point, and the T-Probe guarantees the accuracy of the measurements. What's important here is that the process not only simplifies the task, but also dramatically increases the efficiency. The operator no longer needs to switch between different tools or visual references. Everything they need is projected directly onto the part they're working on. And let's see it in practice. Okay. As you can hear, this is the Polyworks probing sound. Now we're going through all these points, and here we finished already. So why does it matter? With the augmented reality projections guiding the probe, measurements are taken from the exact locations required without any deviation. The process is faster because the operator can focus on the probing points displayed in real time, minimizing downtime spent checking manuals or external software. The learning curve for this method is significantly reduced as the operator simply follows the projected guide. Even complex parts, like this car door, become easier to inspect accurately. By using Spotlight AR++, the entire measurement process is streamlined and the possibility of human error is reduced. This not only saves time, but also ensures that the inspection results meet the high precision standards required in industries like automotive manufacturing. In conclusion, the combination of Spotlight AR++, the Scantek TrackScan T probe, and Polyworks Inspector creates a powerful, intuitive system for guiding measurement inspections. It allows you to focus on the task at hand, knowing that the technology is ensuring accuracy every step of the way. Thank you, and now Tamás is going to continue with assembly guidance.
Thank you, Daniel, for giving me the mic once again. Our next application is the Spotlight AR assembly guidance. We will show this application within a pre-recorded video, which I will narrate. Let's watch the video together. The assembly guidance greatly simplifies daily tasks in factories, such as assembly processes on production lines. In the video, we can see a part assembly process. The unit being assembled is this electronic assembly of the Smart Station motion controller. Let's talk a bit about the software structure of the assembly guidance, which is simple and logical. First, we need a layout within which we can define the required workspace. Within this workspace, we will place the necessary tools and the components to complete the assembly. Afterward, we create a Polyworks Inspector project. Within the project, we define the size of the workspace where the components and the tools will be placed. Inside the layout, we define the assembly location, the exact positions of the parts, and the position of the required tools and fasteners. Additionally, in Polyworks, we will need an assembled CAD model to determine the exact locations of the parts to be assembled. We can label the parts and tools using projected labels, and instructions can also be projected during the processes, so the operator knows exactly what to do during the assembly. Once the layout is completed in Polyworks and we have included all the necessary elements that Spotlight can project, these elements can include the following. For example, the position of a tool can be defined and projected with a rectangular element, while a label can be placed on a plane, or we can assign a custom value to a comparison point where we store the instruction. The exact location of the parts during assembly can be determined by projecting CAD models, so once the layout is ready and we have the exact steps for the assembly and we know the position of all the elements. We open Spotlight AR++ and use the presentation mode, which is similar to a slideshow. We use multiple scenes during the projection, which will represent the steps of the given process, where we place the elements to be projected. This simplifies assembly processes during production, increasing manufacturing efficiency. There is no need for paper-based work instructions, which is beneficial because if something changes during the assembly, revision is necessary. This means the old paper-based work instruction must be discarded, and after modifying the instructions, they need to be reprinted. This is environmentally harmful and inefficient. Operators need to be retrained since change occurred in these processes. With assembly guidance, if changes occurs, it is enough to modify the program, saving time and effort. Also, operators do not need to be retrained because assembly guidance clearly defines the assembly steps. Another advantage of the applications is that it gives clear instructions to operators, reducing the chance of guesswork. Even complex processes can be broken down into simple steps to train operators, increasing the efficiency and quality of the training. One popular application area is determining the wiring of parts or units. In situations where a lot of cables run between certain parts, we can use projections to clearly indicate where each cable goes, again improving assembly efficiency. This solution is also useful when maintaining very old machines or units where the maintenance process is not clearly documented, such as in the aviation industry during the assembly and maintenance of aircraft turbines. In summary, assembly guidance is a very useful industrial application as it increases manufacturing efficiency, assists operators in their daily tasks, simplifies learning processes, and makes work processes clearer. It is versatile and user-friendly software for engineers. Thank you once again for your attention. I would like to hand the mic back to Daniel.
Thank you, Tamás. In our last section, I'm going to demonstrate how Spotlight AR++ utilizes dynamic projection for the inspection of a valve mounted on a UMA Smart Station rotary table using 16mm retroreflective spheres as alignment points. First, let's set the stage. The valve is positioned on the UMA Smart Station rotary table, which allows for precise rotation and adjustment of the part during the inspection of or assembly processes. To ensure the accurate alignment between the physical valve and the digital model, 15 reference spheres placed strategically around the valve. These spheres act as alignment markers, allowing Spotlight AR++ to synchronize the projection with the exact position and orientation of the valve. Now, here's how the process works. The valve is placed on the UMA Smart Station rotary table and secured in position. Around the valve, 60mm spheres are mounted as reference points. These spheres are critical for aligning the augmented reality projections with the real-world object. After a proper definition of these 16mm spheres, precise alignment is done between the CAD model and the physical valve. This ensures that the projection that will be displayed are accurately mapped to the surface of the valve, regardless of its orientation on the rotary table. Once the alignment is confirmed, Spotlight AR projects real-time dynamic information directly onto the valve. The projected data follows the valve even as it rotates on the UMA Smart Station rotary table. The dynamic projection means that as the table rotates, the projected information moves accordingly, maintaining perfect alignment with the valve. This allows operators to see exactly where to inspect, assemble, or perform other tasks, all in real time. Since the system is dynamically updating, there is no need for manual repositioning or rechecking of reference points during rotation. The UMA Smart Station rotary table and the 60mm alignment spheres work together to ensure that every projected element is precisely where it needs to be. The operator can rotate the valve to the optimal position while the AR system continuously updates the projection to match the valve's movement. In summary, the combination of Spotlight AR++ dynamic projection, the UMA Smart Station rotary table, and the 60mm alignment spheres provide a highly efficient and accurate method for inspecting and working on complex parts like this valve here. I would like to highlight that there is no need for more projectors. With one projector, it is possible to visualize every deviation on the part, saving money on hardware and space around the working area. The spheres ensure the perfect alignment, and the dynamic projection adapts in real time as the part is rotated, providing operators with clear, actionable information throughout the entire process. Thank you for your attention.
Bye-bye. Have a nice day.